So today we are going to discuss the projectile motion of a body. Basically, the projectile motion is the motion that is possessed by a body when it moves in two dimensions or two axes. Suppose in your case, I have taken two axes, two dimensions, x and y, and a body is projected from an origin position O with velocity v, and as it is projected in the air, it will cover up the distance and will land at any point. This starting point is called the point of uh, projection, and that point is called the point of landing. And the velocity is resolved into its basic component, that is initial velocity, and the final velocity, that is initial velocity along x-axis and initial velocity along y-axis. Whereas at the top peak, that is also called the summit point, the maximum height, at there the y-axis will wipe out. Here y-axis will equal to 0, and in this case the x-axis, x component, will only exist. One more thing that is important to know, that along the whole journey the x component will remain the same and it will not be changed. You can check it in from the graph that the x-axis value is not varying, so x-axis will remain constant throughout the whole motion, whereas the y-axis values will changes with time to time. So here I have developed some important equations that are related to the projectile motion that can be derived using the three motions of equations. The time period, that time is the total time that is required by a body by following this path from one position to the point of projection to the point of landing, that is 2 initial velocity sine theta over g, whereas the height is the maximum summit point where a body has reached. So this height is calculated using second equation of motion, that is equal to initial velocity square sine square theta divided by 2g, whereas range is the maximum area that a body covers along the x-axis, that is given by v I square sine 2 theta divided by g. So these things, you can check out that time has a direct dependence on the initial velocity. Similarly, height has got direct correspondence with the initial velocity. Similarly, the range has got the direct link with the initial velocity. So we are going to check our projectile motion. I have developed a Python based code and check what type of the animation this is going to show with us. So first I have three different programming here, developed Python's base coding in the Python to check out the results, what kind of the result is predicted as in the projectile motion. So first I have run this file and I am waiting for the result. My computer is a bit slow, but here you can see the beautiful animation of the projectile. So it is started from a 0 point, that is point of projection, and you can check it out that it is reaching toward its maximum height, that is already studied on our white circuit board. Now this will go back and reverse its motion, invert itself, and will come to the point of landing. So here the animated projectile motion can be seen. I have also developed one more code. Think I can check it out here, where for this case that is already presented, we have taken the initial velocity that was equal to 10 meter per second, whereas theta was taken as by 45 degree. Now I am going to run the second Python file that I have prepared, so you can check it out here. It is showing us the results of the Python directly. It is only plotting based. So I have adjusted this graph, and you can check it, that horizontal and vertical distance covered by the body. So as the point of the at the point at which this was launched is at the 45 degree angle. So at 45 degree angle, the projectile is having the maximum horizontal range, and it is covering almost above 250-meter distance. So here in this case, I have set the initial velocity in code B is 50 meter per second, and theta is 45 degree. The third one is also present here. I will check it, and after running this code, let's see what type of the result is going to be expected here. It will going to ask us the values, what kind of the initial value we are going to present. For example, I am going to put the initial value at 50 meter per second, and it is asking for the initial angle. Suppose I am going to put angle as a 60 degree. So what result is going to be happen? Let's see here. Our result will be presented. My computer is a bit slow, that's why it is taking time. So here is the result that is present before us, having initial velocity 50 meter per second and at the angle 60 degree. One more thing that is important to know, that it has direct dependence on the initial velocity and the angle of projection. For 45 degree angle, it will present, it will go maximum range, whereas if we change the angles, it will fall in a complementary angle style. For example, the projectile presented by 60 degree will also be the same result predicted by 30 degree angle. So now come back to the screen. Let's go. So here back. So in this case, we have studied the projectile motion in animated series and try to understand the real concept of the projectile motion. If you have any questions regarding it, you can ask these questions in the comments. Whereas if you need these Python based coding of the projectile motion, you can also comment below. I can provide you these codes as well for your better understanding. Thank you for watching our video.